We are going to see linked list. So the definition of linked list is a linked list is a data structure that stores a sequence of elements. Each element in the list is called a node, and each node has a reference to the next node in the list. The first node in the list is called head, and the last node in the list is called tail. Here I give one example for this linked list. There are three nodes are given here. This is the first node. As the definition, this is we call it as node, and each and every node contains, there are two parts. One is data part, another one is link part. So the data part is holding the data value, and the link part it used to point the next node. Like a way, each and every node which is linked together. Okay. What are all the advantages of a linked list means? A linked list is dynamic. Why it is called as dynamic means we have to compare with array. If you have any clear idea about array, just you go through my array video. So what do you mean by array here? Array, it is nothing but, suppose in that array video we are representing array, it is ARR of 5. ARR it is nothing but array name, and 5 it is nothing but 5 memory locations we have to allocate for this array. What is the difference between linked list and array means? In array we are occupying 5, we are what we say, we have to allocate the memory space well in advance before we are starting the program. Whereas in linked list there is no such necessity. Whenever the memory portion it is needed, at that time we are taking one node and we are using that node and we are attaching that node in the linked list. So that's why it is called a linked list is dynamic. Then the linked list is not required to be continuously present in the memory. So in array the continuous memory locations are occupied well in advance, that memory space which is used in the program. Whereas in the linked list, the array memory location it is not continuous, it may be then and there we are able to use the memory space. Does not need to be declared in advance. So we already know that it is not declared in advance. Whenever we need it, we are taking the memory space in a node format. Empty list cannot be present in the list. So as we know that whenever the necessity it comes, then only I am able to take one node and I am using that node. I am after filling the data part, I am attaching that node in the existing linked list. So that's why there is no empty list in the linked list, empty node in the linked list, and it helps to reducing the access time. So when we go for accessing the each and every node, we will go through this idea in detail. Okay. So this is what the picture of that linked list. Before I am going to traversing a linked list algorithm, I want to explain this particular information. What is it? Each and every node which contains two parts, one is data part, another one is link part. So in a data part, I am storing the value in the data part. In link part, I am storing the address of the next node. For example, the address of next node is 100 means that number 100 is placed here. Suppose this node memory location is 200 means that 200 is placed here. So through this address space only in the link part, it goes to the appropriate address. So I'm making one link here. Virtually the link is not placed. The memory address of this node it is given here in the link part. So through this address only, it used to find the address of the next node and it takes the value of that particular node. So this is data part, this is a link part or address part of the next node. Okay, so how can we do? Each and every node have data part and link part. Whenever the data part process is over, through link part, what address which is given here in the link part, accordingly I have to find it out the next node. Okay, so this is what we are doing. As far as this particular linked list, we are taking the first node is called a head node and the last node it is called a tail node. So as we already discussed it, what is it? Head and tail. This is head node, this is tail node. Head node it is the starting node and tail node is the end node of the particular linked list. Okay, so from the head node I am used to traverse one by one through this algorithm, traversing algorithm. Before that, what do you mean by traversing? Traversing it is nothing but going node by node in the particular linked list. That is, we call it as traversing, moving one by one. Okay, so we traverse from the head node to the tail node of the particular linked list. This is, we call it as traversing. So in this algorithm, in this traversing algorithm, we used to start step 1 as pointer equal to head. So what we do means, we are taking this node, head node, according to the head pointer, and we make this node as a pointer node, PTR. So abbreviated term is PTR. So pointer PTR equal to head. Okay, so we are making a pointer in the head node. After that, we are checking that if pointer equal to null, pointer contains here value that is not null, so that's why it is not null, so that's why it come to the third step. Suppose it is null means, what happens? Write empty list, go to step 6. Step 6 is, we are exiting the process, we are unable to do any process because the first node itself empty, so that's why we are unable to traverse any node because the list is empty linked list. Okay, so if it, here in this current scenario it is not null, so that's why I come to step 3. What is step 3 here? Step 3 is repeat step 4 and 5 until pointer not equal to null. What is given here? It is not equal to null. So this symbol represents, as already we know that this is the not equal to symbol in the program. So that's why I am using this symbol here, pointer not equal to null. What about the pointer here? The pointer having value, it is not equal to null. So that's why what I do? I have to do the step 4. What is step 4? Step 4 is print pointer data. Traversing it is nothing but we are going node by node. At the time of traversing, I am taking the value from each and every node and I am printing each and every value from head to tail. Okay, so that's why print pointer data. What is pointer? Pointer is here, data column is this one, so that's why I am printing pointer data. Pointer data is 12 here, so I am printing the value data part here, print pointer data, then pointer equal to pointer next. So how can we traverse the pointer from here to here? We go to the link part. In the link part, the second node address is given, so I am taking this address, I am going here. So that's why now the pointer is moved from here to here. So now pointer comes here. Okay, and this is end of the loop. Once again we go to third step. In third step, I am checking repeat step 4 and 5 until pointer not equal to null. So we are checking the condition here, pointer not equal to null. What is the pointer value here? Pointer it is 20, it is not equal to null. So this is the data part, pointer dot data. What is the data value? So it is value here. So that's why I am coming here. We are executing step 4, print pointer data. What is the data value here? It is 20. So pointer data it is 20. I am printing 20. After printing the data, what I do? I have to move the next node. So in this step it represents this pointer equal to pointer next. So that's why the pointer it comes here. This is pointer now. Once again I come to step 3, repeat step 4 and 5 until pointer not equal to null. If the condition is true, then only it executes 4 and 5. If the condition is false, it comes to step 6. It terminates this loop and it comes to step 6. So now the condition is true, so not equal to null, so it is having value 28, so that's why it comes here, it is executing step 4. So print pointer data. What is pointer data? This is the data column, pointer data, it is 28, so I am printing number 28 and I am moving pointer equal to pointer next. Now the pointer, it moves from here to here, PTR goes next node. So there is no next node, it treated as null. Okay, so once again the control comes here, repeat step and 4 until pointer not equal to null. So in this case pointer is null, so that's why it is not executing step 4 and 5, directly it comes to step 6 and it exit from the loop. Okay, so through this way only, traversing each and every node in the linked list, it is executing. So that's all friends, thank you.